example of an automated system and try and break down how it works. So here we have a science research center, and as you can see, in the science research center there is a gas chamber. Inside the gas chamber there is a deadly nerve gas. Now, of course, if the deadly nerve gas escapes from the gas chamber, that will cause harm to humans who are working in the Science Research Center. So really, we need an automated system to alert the humans in case the nerve gas escapes from the gas chamber. Of course, we could employ a human to do that job. A human could sit in a chair with some kind of gas sensing device 24 hours a day, every day of the week, waiting for the gas to escape from the chamber. But rather than employing a human to do that, which might be quite costly, a better option is to set up an automated system. Here it is. Let's see how it works. Now here we have a gas sensor. The gas sensor is simply detecting the gas level in the research center and sending that data somewhere. Now, the gas sensor actually is sending the data to a computer. The computer is collecting the data that's being input and using that data to make a decision. Now, this computer is super basic. There's no fancy monitor, there's no graphics card, there's no video card, there's no fancy keyboard. It's really just a super basic, bare bones computer. In fact, I'm going to call it a microprocessor. So the gas sensor is sending data into the microprocessor. So sensors are known as input devices. A gas sensor is detecting information from the natural world, gas. This is an example of analog data. Now, microprocessors and computers don't understand analog data, they understand digital data. So this red box here is converting the analog data coming from the gas sensor into digital data so that the microprocessor can understand it. Now, as you can see, the gas sensor sends data continuously. It doesn't really care what the data is, it's just sending the data. Gas level data, gas level data, gas level data. It's pretty stupid. It's useful though, because it continuously sends gas level data to the microprocessor. How does the microprocessor know that the gas level data is okay, it's not dangerous, so the microprocessor doesn't need to do anything? How does the microprocessor know that it doesn't need to do anything? Well, the answer to that is, inside the microprocessor's memory, there is a stored value. Let's look at an example of that. Let's say that the stored value in the microprocessor memory is 5. And the gas level data coming from the gas sensor is 1. So the microprocessor does a little calculation. It says if the gas level data coming in from the gas sensor is less than 5, which is the stored value, then I'm not going to do anything. We can represent this idea using this algorithm. We input the data, we check if the sensor data is less than the stored value, then we don't need to do anything. But what if suddenly the gas escapes from the gas chamber, the gas level increases to more than 5, more than the stored value? Oh my goodness, I'll tell you what, let's simulate that. we're going to be a little bit naughty. Don't do this at home. We're going to break into the gas chamber and release the gas into the Science Research Center. Hopefully, the microprocessor will see that the gas level data is greater than the stored value, and it will send a signal to activate the output device. Let's see this working. Whoa, the gas has escaped. Oh look, a signal has been sent to the output device, and the alarm has been sounded. So that's how this automated system works. The gas sensor, which is an input device, sends analog data continuously to the microprocessor. In order for the microprocessor to understand that data, we need to convert it to digital data. If the input data is greater than the stored value, the microprocessor will send a signal to activate an output device. In this case, the output device is an alarm. And that is an introduction to automated systems.